sessions we discuss about various types of loadings, various types of beams and support reactions, and hopefully you people have already gone through the previous lectures that I have uploaded. Today we will discuss about some other very important topics related to shear force and bending moment. Okay, so first of all what we will discuss is the definitions of shear force and bending moment, and later on we will discuss about the sign conventions that are used in shear force and bending moment diagrams. Okay, so when we start off with the definition of shear force, so our topic is shear force and bending moment and bending moment. Okay, so the first topic that we will discuss is shear force. So first of all what we have to understand is what is meant by shear force. Now for understanding shear force, let us first write down the definition of shear force, then we will try to discuss. So according to the definition of shear force, it is said, or it is defined as the algebraic sum of forces acting either on the left hand side or right hand side of the section that we have considered. Okay, so obviously as because shear force is a force, therefore the unit of shear force will be, obviously it will be in Newton, kilonewton, or in other higher or lower units. Okay, so let us discuss about the definition of shear force. So as per the definition that I have written here, it is said that it is defined as the algebraic sum of the forces acting either on the left hand side or on the right hand side of the section. Now first of all what you have to understand is what is meant by a section. Okay, so let us consider an example first. Let us consider that we have got a simply supported beam. I am just taking an example, it can be any type of beam. So suppose there is a simply supported beam here, and for example we have got one force which is acting at this particular point. Let us consider that the span of the beam is AB and this is point C. Okay, now you have to understand first that when a force is acting on a beam, there may be two conditions that is applicable. Okay, the first condition is that the beam will break due to the action of the force, and that breaking will be due to the shearing action of the force that we have applied externally. Okay, so if we take an example like this, suppose we consider the section here at this point C, then by the application of this load, this beam can break into two parts. This beam can break into two parts. Okay, so the beam can break into two parts like this. Suppose the beam has broken into two parts like this. Okay, or in other conditions also the beam may break into two parts. Let us draw it nicely. So this is the breaking portion, this is the breaking portion. So if this initially the beam looked like this, due to the action of some force the beam is tending to break at a particular section, and afterwards we have seen that the beam has been divided into two parts due to the shearing action, right? Now this shearing action is due to the application of an external force which we consider to be as the shear force. Okay, now this shearing action can divide the beam into either this particular example, or it can also break or shear the beam like this. Okay, so I was talking about section, right? So the first thing that I have discussed here is about the definition of shear force. And what is a shear force? Shear force is the force by the application of which there will be a breaking in the beam at a particular point, and due to the breaking there will be shearing action. The breaking will be due to the shearing action that has been seen, and the beam can break into two parts like this as well as this. Okay, now we already know that wherever you apply a force on the beam, doesn't matter where you apply the force, the beam is not actually moving, it is in static equilibrium. So as per the condition of static equilibrium, we know that summation of fx is equal to 0, summation of fy equal to 0, and summation of m is equal to 0. What is summation of fx, what is summation of fy, and what is summation of m? Let us discuss. Summation of fx means it is the sum total of all the horizontal forces that are acting on the beam. Okay, summation of fy means it is the sum total of all the vertical forces that are acting on the beam. Okay, and summation of m means that it is the summation of all the moments that are acting on the beam. Now if a body is in equilibrium, then summation of fx, summation of fy, and summation of m value will be equal to 0 for every condition. Obviously if the body is in equilibrium, or preferably static equilibrium condition. Okay, so in case of a beam, when we consider, the beam is always in static equilibrium. So summation of fx, summation of fy, and summation of m will be always equal to 0. And that is why if you want to calculate the shear force or bending moment for a particular beam, then we always take a section in the beam. Okay, for example, if I have a beam like this, now suppose the length of the beam is L, length of the beam is L, and the span is AB that we have considered here. If we consider a section, if you want to consider a section in the beam, then you can take the section of the beam by considering an origin point. Okay, and you can consider the origin point acting on either of the sides. For example, I can take the origin point here, or else I can take the origin point here. If we take the origin point here, if we consider the section like this, suppose this is the section, this is the section, and we consider this to be suppose x section, then if we are considering the origin point or the origin point is on the left hand side of the section, extreme left hand side of the section, that means if we are considering from left to right, then at this point x value will be equal to 0. Okay, and at this point the x value will be equal to L, as because the length of the beam is equal to L. Similarly, if we move from right to left and we consider the same diagram here, suppose this is the beam and the length is L, and we are considering this as A point and this as B point, and we have considered a section here just similar to the previous condition. Here we have considered X section, and if we are moving from right hand side towards the left hand side, then this is the right hand side of the beam, this is the left hand side of the beam. So if the origin point is taken on the right hand side at point B, then here the value of x will be equal to 0, and here the value of x will be equal to L. Okay, just the opposite that you have seen here. Okay, so as I have already said that if you are calculating shear force or bending moment for the whole section, then obviously the summation of fx, summation of fy and summation of m will be coming 0. Therefore we consider a section at a particular point and then we are calculating the shear force and bending moment at that particular point. Okay, so this is how we consider the sections. If we move from left to right, if we move from right to left, then we have to consider the origin accordingly. Okay, and then we have to move forward along the span of the beam. Okay, now the sign convention related to shear force has to be discussed. Okay, so what is the sign convention related to shear force? Okay, so suppose I have considered an beam which looks like this. Okay, suppose we have got a support here, we have got a support reaction here also. This is point A, this is point B, we have got this is RA and this is RB. Suppose we have got an uniformly distributed load here like this. Okay, and suppose we have got a point load acting at this point also. Okay, just an arbitrary condition we have taken. Okay, now if we are considering the section at this point, suppose this is the X section that we have considered, which is acting at, suppose AB, let us name this as point C and let us name this as point D. Okay, now you have to make sure that whether you are moving from left to right or you are moving from right to left. If you are moving from left to right, then we will consider all the forces from left to the section and calculate the shear force. Okay, I am repeating this. If you are moving from left hand side of the beam to the right hand side of the beam, that means from here towards this right hand side, then we will calculate the shear force only between point A and point C, as because from A is the extreme left end and C is the section where we have considered. C is the point through which we have considered the section. We will only consider the loading up to the section, taking into consideration whether we are moving from left to right or we are moving from right to left. If you are moving from right to left, in that condition you will be considering from B point to C point all the loads and calculate the shear force, and in case of bending moment you will be calculating the bending moments also. Okay, so we are talking about shear force here. So in this condition we have considered the section here, so we need to calculate all the shear force from point A to point C when we are moving from left to right, or if we are moving from right to left, then we will be considering all forces that are acting from point B to point C in order to calculate the shear force. Okay, now what is the sign convention? So for considering the sign conventions of shear force, what we will do, we will consider a force which is acting in the upward direction to the left of the section to be positive, as well as if we consider towards the right of the section, and if a force is acting on the downward direction, that will be also considered to be positive. Okay, this means that, for example, let us take an example here. Suppose we have got a beam AB and we have one force here acting. Suppose this is RA and we have got the section here. Okay, and another force is acting. Suppose this is P force. Okay, and we have got another force here RB, and we have got another force here which is suppose Q force. Okay, now if we are moving from left to right, then obviously we are considering forces from this point to this point only for calculating the shear force. I have already discussed in the previous portion. Okay, so when you are calculating the shear force from this point to this point, we have got how many forces? We have got this RA force and we have got this P force acting. Okay, what is the direction of RA force? RA force is acting in the upward direction, is acting in the upward direction. Okay, so this RA force has to be taken positive, has to be taken positive. Okay, this is number one condition. Number two condition is, let us draw the section here. If we have a force on the left hand side of the section which is acting downwards, that has to be taken negative, as well as if a force is acting upwards to the right hand side of the section, that has also to be taken negative. So let us tally these two conditions and check it here. So for this condition, if we are moving from left to right, then RA force is an upward force, therefore this force is towards the left of the section, that has to be taken positive, right? So RA is positive. P force is also to the left hand side of the section, so left hand side of the section, if the force is on the downward direction, that has to be taken negative, right? Similarly, if you are moving from right to left, in this condition you can see RA, RB and Q are the only forces which are acting towards the right of the section. So RB force is acting upwards. So you can see here, if any force is acting right to the section and is acting upwards, this has to be taken as a negative one. And Q force is also a force which is acting towards the right of the section and acting downwards. So you can see, if a force is acting downwards, this has to be taken to be positive, obviously if this force is towards the right of the section. These are very important for calculation of shear force regarding any problem. Okay, now let us discuss about bending moment. Okay, So I have said that there will be a condition if a force is acting on a beam. In the previous section you can see, if a force is acting on a beam, then the beam may shear. That means it may break at a point and there will be shearing action and the beam will be broken into two parts, two or more parts, depending upon how many forces are there. Okay, if for this example I have considered that the beam will be broken into two parts. Okay, but in some cases also, I mean in most of the cases, you will see that if we have a beam like this and suppose we have got some support here, okay, now if there is an application of a force which is suppose P, this is span AB, then in most of the condition you will see that there will be a deformation in the beam that is taking place. Now for the action of this force P, this beam will tend to bend like this, which is bending means deformation. Okay, so the beam will tend to bend like this. Previously the beam was like this. After the application of force P, the bending takes place and the beam has undergone deformation. Okay, now this is due to the bending moment that is acting in the beam. So let us first write down the definition. So according to the definition of bending moment, it is defined as the algebraic summation of moment of forces acting on the left hand side of the section or right hand side of the section. So it is very much similar to the previous condition. In case of shear force, we were calculating the algebraic summation of the forces, but in this condition when we are calculating bending moment, then we were calculating the algebraic summation of the moment of the forces, not the forces but the moment of the forces. Here also we have to understand that we are calculating the moment of the forces either to the left hand side of the section or to the right hand side of the section. This has to be understood. Okay, now let us discuss about the sign conventions. Now when you are discussing about the sign conventions, you have to keep in mind that if we have a section like this and suppose we have got a clockwise movement on the left hand side of the section and on the right hand side of the section if you are having an anti-clockwise movement, then this has to be taken as positive moments. I mean both of these are to be taken positive. Okay, this type of movements that we see here, these are due to the sagging in the beam. What is sagging? Sagging means the beam will tend to bend like this. This is known as, if the after deflection the beam looks like this or similar to this, then you can understand that this is known as sagging of the beam. Okay, this is sagging. Okay, now the other condition is if you have a section here and we have got one anti-clockwise moment along this direction, and here we are having a clockwise moment along this direction. Then both of these are to be taken negative. Okay, and due to the action of these moments, this on the left hand side, this is the left hand side and this is the right hand side. If you see that on the left hand side of the beam, left hand side of the section, there is an anti-clockwise moment acting, then that has to be taken negative. And if you see that on the right hand side of the section, there is an clockwise moment, that has to be taken negative. Okay, and this is due to the application of these moments, and hogging of the beam is noticed. Okay, hogging means the beam after the application of the moments will look like this. This is known as hogging. Okay, so keep one thing in mind, that if the beam bends like this, then this will be due to the action of a clockwise moment towards the left hand side of the section and a anti-clockwise moment towards the right hand side of the section, then sagging will be noticed. And if you have a hogging action that you see, then this hogging action will be due to the application of a anti-clockwise moment towards the left hand side of the section and a clockwise movement towards the right hand side of the section. So these two are to be taken negative and these two are to be taken positive. These are very important. This you have to keep in mind when you are solving problems regarding shear force and bending moment. Okay, so today up to this we will be discussing about other topics, broader topics and problems in the next classes. Thank you all.